This is going to be a slightly more challenging one, but I hope that you can actually do this exercise without using your calculator, okay? So how do we do something like this? On the inside, this is 0.9, and actually that's equal to 9 over 10. So what we can do in this case is that we'd say it's 9 over 10 times 9 over 10 times 9 over 10. So the end result is that I'm saying it should be 9 cubed divided by 10 cubed. So that's going to be 729 on the top divided by 1,000. And so the way we divide by 1,000 is we move digits to we move the decimal place basically to the left, and we shift and make the digits smaller, right? So in this case, 0.729, this is how you would actually have it, right? So um, we'll start from the beginning here, right? This is 7 over 100. So if we multiply the top and the bottoms by themselves, it'll be 49, not just over 100, but over 10,000, right? So if we wrote out 49, we'd say, okay, that's 1, that's 2, that's 3, that's 4, right? And then we should actually have this number here, right? Very similarly, we're looking at 9 divided by 10,000, so we're looking at 1, 2, 3, 4, right? That's how many decimal digits it needs to go over. When we look at this number right here, it's going to be 100 times 100 times 100 in the denominator, which is actually going to be a million. And then, so that's 6 digits in the denominator. And at the top, we're saying, oh, this is 8 times 8 times 8, which is actually going to be 512, right? So if we did 512, we're going to have to shift by 6 places. So 1, 2, 3, 4, 5, 6, right? And that's how many places we'd actually need to be able to scooch over by, right? Over here, this is 2 over 10, so suddenly it becomes 8 over 1,000. So 8, and then 1,000 is going to be 1, 2, 3 digits, right? And then, again, we've encountered this problem before, so it's going to be 729 on top, divided by 1,000, so 1, 2, 3 decimal places, right? 6 to the third, 6 times 6 times 6 is going to be 36 times 6, which is, what, 216? And then we need to shift by 3 decimal places, so 1, 2, 3. We're going to have exactly that, okay? As we keep on going from here, this is going to be 0.2 times 0.2. So 2 times 2, which is 4, divided by 100. So there we go. We can type the 0 here, or we can, not type it. It doesn't really matter. Some teachers prefer to have it and others don't. I am ambivalent. I don't really mind if you put it or not. So in this case, when you have 0.1, we're going to multiply basically, this is 1 over 10 by itself, so you're going to get 1 over 100. So 0.01, just like that. You're going to get 5 times 5 times 5 on the top, and then a million in the bottom, so 125, and then 1, 2, 3, 4, 5, 6, right? And you can actually count this very quickly. In this case, this is 4 cubed, so 4 times 4 times 4 is going to give you 16 goes to 64, right? So you have 64 here, and then because the bottom was 100, right, so this is written as 4 divided by 100. I can write it as other fractions, but the reason I keep the tens and the hundreds and the powers of 10 is because it's so easy to just move left or right, to move the decimal point left or right. So in this case, it's divided by a million, so we're going to have to shift by 6 places. So 1, 2, and then 3, 4, 5, 6, right? So that's essentially what we're going to get there. As we get this one, 4 squared is 16 divided by, again, it's going to be 10,000, so 1, 2, 3, 4 places, just like that. 6 cubed will be 6 times 6 times 6, which is, again, 6 times 6 is 36, times 6 again is 216. When we see these numbers enough, we will recognize them. They'll become our friends. And then on the bottom, again, we're looking at 100 cubed. So 100 times 100 times 100, what do we get? That's going to be a million. So we need to shift by 6 places. So 1, 2, 3, and since we don't have any more, 4, 5, 6, right? And we'll put the decimal point right there. 2.2, this is the first one that's kind of interesting now, right? Because we're actually going to multiply by 22 over 10. But notice sometimes you don't have to do that much work since this is just to the power of 1. Anything to the power of 1 will equal itself, okay? Uh, Over here, when we deal with this, this is going to be slightly harder, and I would actually encourage you to take a sheet of paper out so that you can actually figure it out, okay? But essentially what we have to do is multiply by 58 over 100 times 58 over 100. 58 times 58, we have some tricks for it, okay? So if you really wanted to think about it, um, you can say that this is uh, 50 plus 8 or 60 minus 2, however you want to think about it, and that quantity squared. Using some algebraic tricks in the future, you're going to figure out that it's actually going to be 3,364, okay? And so basically that divided by the 10,000 will give us 0.3364. I do not mind if you take a piece of paper and write this one out because it's going to be a little bit confusing if you don't, right? Um, as we continue from here, right? If we look at this, this is going to be 12 over 100 and then cubed. So we should all know that 12 times 12 is going to be 144, right? But you know what happens when we multiply that by 12 again, right? So go ahead, take out a sheet of paper, and really do calculate it. If you want to do mental math, that's really great. I think that if you really aspire to be good at math, you should be able to do this. But otherwise, we're going to go with 1728, right? And I'll teach you how to do that. If you had 144 and you want to multiply by 12, 12 is just 10 plus 2. So what we do is 144 times 10 gives us 1,440, and then the 2 times 144 is just 288. So basically, we just go ahead and add those together, and we're going to get our number, right? The 144 times 12, it should be really, really straightforward just like that. But again, when we look at the bottom, it's going to be 100 squared, so that's going to be a million. So 1, 2, 3, 4, 5, 6, and then bingo, there we go, right? Any power to the 0 power will equal, or any base, sorry, to the 0 power will equal 1, okay? This is 4.5 squared, and again, we can convert it to a fraction if we'd like. Otherwise, we can, really just write this out and multiply. I prefer converting to fractions because it's just easier for me. This I view as 9 divided by 2. Notice that we're not dealing with tens anymore. We're dealing with 9 over 2. And so 9 over 2 squared will be 9 over 2 times 9 over 2, which is 81 over 4. 81 over 4 will divide into 20.25. Okay? So the harder problems, these are getting a little bit more tricky, right? But it's not too bad. So we'll be able to do these, all right? And then, again, anything to the 0 power is 1. As we continue from here, what we see is 2.5 squared. So remember, if we're dealing with 2.5, that's actually just going to be 5 divided by 2. 5 divided by 2 squared will give us actually 25 over 4. 25 over 4, if we divide, we can do mental math, and it'll be 6.25, or 6 1/4, right? Anything to the 0 power is, that's right, it's 1, okay? When we take this number cubed, okay, this is probably the hardest problem that we've had up until now. We can think about it and really try, but even for this one, I'm going to go ahead and grab a sheet of paper, right, and really write this down. So if you think about how to actually go ahead and multiply these numbers together, right, you just go ahead and multiply 53 by 53 by 53, and you hit the shift it by a total of 6 digits because the denominator in this case will be a million again. So if we multiply the first 53 by 53, we're going to get, I think, 2,809, and then we're going to multiply that by 53 again, and that's going to be a slightly bigger number, right? But I think it should be 148877, right? And then we can actually put 1, 2, 3, 4, 5, 6 digits in front, and so there we go, right? This one, what a relief, it's actually to the first power, so it's just equal to itself. When we take 72 and then square it, right? So if we multiply 0.72 by 0.72, we were just multiplying by 72 over 100 times 72 over 100. And you can use the tricks again. So uh, in this case, if you wanted to do mental math, you would take 70 plus 2 times 70 plus 2. That's going to be 4,900 plus the 2 times 140 plus 4. And so what we're going to get is 5,184, right? 5184. And we go by 1, 2, 3, 4 digits. There we go, just like that. Okay? As we continue from here, this is 2 over 10, and we're going to take 2 to the 5th power, which is 32. 10 to the 5th power is 10, is 100,000. So 1, 2, 3, 4, 5, right? And we're going to get that. And then let's see, 0.3 to the 5. So essentially what we're doing is 3 to the 5th, so that is 3, 9, 27, 81, 243, so 243. 10 to the 5th is 100,000, so we're going to count 5 decimal places. So 1, 2, 3, 4, 5. Bingo, there we go, right? Uh-oh. That's my fault. I should have counted 10 decimal places because the bottom was 100 to the 5th. So again, that's totally my bad, and we got penalized for it here, so we shouldn't be able to make that mistake again, right? So this to the 0 power is 1, right? And then let's try to really power through. So 0.34, getting quite lucky with the ones that we get. So this is, again, where we made the mistake last time, except it's now 0.03 to the 4th. So 3, 9, 27, 81, right? And the bottom is 100 to the 4th. So that's going to have 8 zeros. That's 100 million, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? And basically we're going to have this as our solution, right? So up to 97. 0.2 to the 4, 2, 4, 8, 16, right? So we're looking at 16. The bottom would have had 10 to the 4th, which is 10,000. So 1, 2, 3, 4, right? As we continue from here, 0.3 to the 4th, the top will be 3, 9, 27, 81, just like that. So in the future, we'll just recognize 3 to the 4th is 81. The bottom will be 10,000 again, so 1, 2, 3, 4, just like that. And then finally, this will be 2 to the 4th. So 2, 4, 8, 16, right? So we're typing out 16 like this. And then the bottom is 100 to the 4th. So 100 to the 4th is going to have 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, right? And then this will be our number here, okay? Slightly harder, but I think that you can do it. And try doing it without a calculator, but you can use pen and paper, okay?